I'm James and this is a video on how I restored this vintage Bridges tool hand drill from 1957. Now you may be asking, why restore an old drill? You can buy one for 50 quid and it does the job. Well, I'm telling you that this does the job and it has been running okay for the last 60 years. I've had it for 10. Does everything I need: drilling, routing, sanding and sawing even. A bit about the history. It was bought from a junk shop in my local town from a chap who was in the Merchant Navy. He was an engineer, so he probably had a good use of it. I've used it for 10 years with no trouble until now. It has started smoking and sparking. It is a Bridges tool power hand drill. I couldn't find much information on this company, Bridges Tool Power, but the Bridges logo is incorporated and exactly the same as that used by Stanley Bridges hand drills. Still plenty of those on eBay. According to Claire's website of company history, Bridges Tool Power was taken over by Stanley's in 1960. Now the DR type of neonic drill was invented in 1954. So this is a DR5, so I'd say it was a couple of years later when this company was a subsidiary of John Brown. So I don't know where it is, but I can date it to around 1956, 57 before it was taken over by John Brown Stanley. Let's have a look inside. Okay, it's a very simple mechanical drill with the trigger switch here, straight from the mains into the motor, an electromagnetic motor, via this safety capacitor, which is a mica capacitor rated at 0.003 UF, which is 3 NF. It is made of mica, which is a mineral, and apparently you never go wrong, so I won't be replacing that. The gear head goes straight into the gear shaft, which drives the drill. Okay, we have several problems with this device. When I noticed when I opened it, although it was still working, the earth lead has come off. This wire should be connected to the capacitor. Also, I assume this is some sort of fan sat on here, so we're gonna have to think about replacing. I noticed it was getting a little warm when I was using it. I'm sure I could find a fan from a microwave or something to replace that. Also, the grease is old and gunked up. Okay, let's get repairing. I've already cleaned out the wood dust and gunk with this leather needle. I just scraping off. Then I used a brush to brush it off. I also cleaned the casing in hot soapy water. Right, let's do the messy job first. We've got to get the grease out of the camshaft head. So we're going to have to unscrew the top, which is loose. I can't find a way of getting this drill head off. I'm sure there's a way with a hammer or something, but anyway, it's not budging. So I'm just gonna scrape out the gunk and then put it in some emulsion. I'm just going to brush out the grease in hot soapy water using an old toothbrush. Now we've got most of the grease out, but there's still some remaining inside and on the gear camshaft. So I'm going to dose it in this cellulose thinner for a while, which I think will dissolve the grease. The cellulose has successfully dissolved the grease, also on the brush, so I'm going to have a go at it with the brush again. I must mention you should use this in a well ventilated area because of the fumes of the thinner. Also wash your hands thoroughly after touching all the grease and thinner. Now you'll want the innards of the camshaft fairly dry before you put the new grease in, so I'm just going to use this hairdryer to dry it out quickly. So I'm just going to use a machinery grease, not automobile grease, with a high working temperature of 120 degrees. So I'm just going to spoon this grease out and apply it directly to the camshaft. Now the next problem we have is this broken, what I assume is a fan here. It's probably been broken for about 5 years and I didn't even notice. I wondered why the drill was getting a bit warm. So I found this spare aluminium fan from a microwave. I'm going to have to find some way of attaching that to the bottom where there's a gap here. I think what I'll do is make a split in here, force it down and then seal the split up. I might even weld it. Alright, I forced this hacksaw blade through the centre and I'm going to saw a groove down here. I got that fan fitted on. Now we're going to move on to the capacitor. As I say, it's a mineral stone capacitor, so never goes wrong. So it doesn't need replacing. But apparently if you do replace it, you can go don't have to have 250 volts. You can go up to 450 or 600 even. But you have to have the UF rating of 0.003 or whatever's fitted to the drill. You could probably pick up a vintage one that still works. I don't know. So I'm going to have to find a way of getting a contact or the wire in there and then I'll glue it down. Right, I've crimped a contact on the end of this wire and it fits neatly into the mica because it's quite soft. So then I don't have to glue it, but I will, just in case. The glue has dried on the live wire here, so next we want to strip off this earth lead and connect it to the casing. Right, we've got the earth lead on here. It's fixed on over the chassis, but we won't be taking this off again in the next 10 years, so that's secure there. Another problem we've noticed is that the fan now, although over the chassis, is a little too wide to spin, so we're going to have to clip all around the edge with snippers. Right, we've cut off the edges and rounded up the fan and flattened it out and realigned the fan blades again. Looked at lots of solutions for the fixing this fan on the camshaft, including magnets, wood, rubber, solder, but they're all going to melt. No guarantee, because this is working above 100 degrees centigrade. So, in the absence of anything else, I had to look back at the original fan, and this must be some sort of thermal heat resistant plastic. So I've had a rummage round and come up with a washer that may be heat resistant. We're going to try it. So what we're going to do is put some rubbers on then the washer, then glue it on with some heat resistant glue, which may seal it to the rough edges on the shaft here, which may attach it. And if we put enough grease in the bottom, it might not burn out. Alright, I'm mixing this epoxy together and applying it to my heat resistant plastic within 3 minutes. I've just noticed something else that needs fixing. This back plate that fits on the gearing is all bent and out of shape. It's obviously been worn a bit of the hair from the gear shaft, and there's been contributing to the problems. There seems to be 2 notches here and here, and somehow it fixes it into the plating. But I've got to flatten that out. Well, that's the mystery solved. I flattened it out, and the shape makes it clip into the casing, so that's fine, and we're all ready to go. Right, it's 24 hours later. I've given the time for the glue to set and put an extra washer on the end. I have doubts about it. I have faith, but I don't think it's going to work. I think the rubber and glue is going to burn out. So it's test 2. I've just taken the things off to make it easier. See what's going on. Okay, let's try that again. Excellent results. Very happy with that. No burnout. I think it didn't start because there was some friction from the fan edges, perhaps. I'll just look into that. Very happy with that. I think the drill's done now. I'm going to put it back together. We were going to paint it, but I think that'll detract from the character. So all done. Thanks for watching. Just going to have a close-up here of the fan to prove that it is in place and stuck with the glue and the tinkering, and seems to be firm and spins correctly. Yes, that's very it's quite adequate and firm. Happy with that. I've also noticed another problem with the chuck key. It's not the head that's worn out, it's the key. I just need to buy another one. I think these universal ones are also worn out. So the drill is much better than the keys. I'm just going to test this drill now on a piece of wood. Yeah, that seems to be fine. The only problem is there's some sort of delay before it starts. I don't know what the cause of that is. Something to do with capacitor. I'm not electrically minded.